Okay, hello and welcome to my second video problem set. I chose question 5 from problem set number 6, and the question was, in a large randomly mating population, 0.7 of the individuals express the phenotype of the dominant allele A, and 0.3 express the phenotype of the recessive allele A, little a. It says, what is the frequency of the dominant allele and the recessive allele? And for part B, if the homozygous recessive are 15% less than the other two genotypes, what will the frequency of big A be in the next generation? Um, so I started this question off by reading the question carefully because I saw phenotype was highlighted. I saw that 0.3 expressed the phenotype in the recessive, and that's how I started my question. So I'm going to quickly drag over how I started it. This is a scanned version of my problem set. So I looked at the recessive phenotype and I saw that it was 0.3, and I knew that would be q squared with the equation p plus q equals 1, as I assumed that this was in Hardy-Weinberg equilibrium. I square rooted both sides and I got that q was equal to 0.548, which is the frequency of the recessive allele. And then using the formula p plus q equals 1, I figured out that p equals 0.452, which is the frequency of the dominant allele. And for part B, it says if the homozygous recessive are 15% less fit than the other two genotypes, what will be the frequency of big A in the next generation? So I read this and I thought that if the homozygous recessive is 15% less than the other two genotypes, and the other two genotypes are the same, and I made that equal to 1, as you can see here. The homozygous 15%, I made the relative fitness of homozygous dominant and heterozygous both equal to 1, and then that would be 0.85, which is 15% less than both of those. Obviously here's the selection coefficient, but that was just extra that I added in. So I started making the table as we do in class, and I did p squared plus 2pq plus q squared, and these are the three values I got. And then I multiplied each one by the relative fitness of each one. I got a value, and then I totaled these values up and I divided each of them by the total to get the next generation, what they would have. And I times this by 1,000 because I rounded to 3 decimal places, so I times by 1,000, and I got these values for all three of them: the homozygous dominant, the heterozygous recessive, homozygous recessive, and then the heterozygous. And then since the question was stating what will be the frequency of the dominant A allele in the next generation, I tallied up all the dominant A alleles we have in the next generation, which is 2 of these, as we have 2 alleles for this, 1 of these, and then I took the total and times it by 2, and I got this, which is the frequency of the dominant allele in the next generation. And just to put everything out there, this is the entire answer. Thank you for listening.